All right. Here we have a question that reads: A man of 77 kilograms steps onto a 100-meter high platform suspended by a spring. The platform falls down to ground level. A hook holds the platform in place as the man retrieves a 10-kilogram package. The man is on a planet called Bardia, which is being orbited by the moon Ethan. Ethan's orbital period is 3.6 times 10 to the 6 seconds, and the average separation between their center is 3.8 times 10 to the 8 meters. If Bardia has a radius of 8.2 times 10 to the power of 6 meters, calculate the new height of the platform when it first comes to rest. So this question utilizes two units. It utilizes the planet unit and energy. And we'll start with the planets and I'll show why. So here is the diagram of Bardia and Ethan, and we can see the orbital period, the separation length, and Bardia's radius. And the givens are written down here. So first of all, what we need to find is the mass of Bardia. And using the equation, big M equals to 4 pi squared times the average separation of the planet of Bardia and Ethan cubed over gravitational constant times the orbital period squared. You plug that into your calculator, and you will get that Bardia's mass is 2.5045 times 10 to the 24 kg. So this is useful because once we get the mass of Bardia, we will need to find the G value on Bardia. And it's not 9.8 like it is on Earth because Bardia is not Earth. And so here we have G is equal to the gravitational constant times the mass of Bardia over Bardia's radius squared. Plug that into your calculator using the mass that we just got over here and the givens here. We will get that the G value on Bardia is 2.8 or 2.486 newtons per kg. And this is useful because we will need to solve um, the max height of the man when he first comes to rest. And we did the planets first because the second part requires energy. And to do the calculations with energy, we need to find the new G value since it's not 9.8 like on Earth. And so for the second part of the question, I separated everything that happens into events. And so event one is when the guy is on the building and he first steps onto the platform. Event two is when the platform is hooked to ground level. So when the guy is at rest at ground level. And the third event is when the guy reaches maximum height, when the hook lets go of this guy here and he springs all the way back up, or not all the way, but back up to a new max height. So here's the first two events, and here's the second event and the third event. For the first event, the givens are that the mass of the guy is 77 kilograms. The height is 100 meters because the building's 100 meters. And the spring or the spring is stretched by 100 meters when the guy is down here at ground level. So you'll see here using the conservation of energy. Um, when he steps onto the platform and reaches ground level, we'll do the total energy when he's on the platform is equal to the total energy when he's at ground level. And here we go. We have EG plus EK plus EE. And for this part, EK is equal to 0 for when the guy's on the platform because he's at rest. EE is 0 because the spring is not stretched. And for when the guy is at the bottom, when he's at ground level, EG is equal to 0 because he's at ground level, and EK is equal to 0 because he's at rest. So that just brings us to mgh equals 1 over 2 kx squared. And plug in our givens. We have 77 kg. The g value that we found from over here from the planets, and times height, which is 100, equals to 1 over 2 k 100 meters squared. And doing this, we can find that the k value is equal to 3.828. So with the k value, now we can move on to the second part of this energy part, which is when the guy is at the very bottom, he's at ground level, and we're asked when he reaches the max height. And so here is a diagram. So as he goes up, this is the x value, and which is what we're looking for. And this is the height, which is 100 minus x, because the whole thing is 100, and this part is x, so the rest of it will be 100 minus x. And like the question stated, he goes to receive a 10 kilogram package. So his mass has actually changed. It is 77 plus 10, which is 87. And the height is that, and the x value is that. So the second part is when the platform goes up, do the same thing. ET 2 equals to ET 3. And we have 1 over 2 kx squared, which is the same as over here in this part. And we have EG plus EK plus EE. Now, when the guy is at max height, the third event, his EK will equal to 0 because his velocity is 0. And what we're looking for is the x value. So here we have EK equals to EG plus EE. Plug in the K value, plug in the new mass, plug in the G value we found from earlier. Height is equal to 100 minus x, and we're looking for x. After that, we plug it all in, we'll be able to get a quadratic equation. It'll come down to this equation, in which x is equal to 100 and 12.99. And this x is equal to 100 because if you plug x into the equation, you'll see that the two sides are equal to each other. And this is basically it's basically stating or telling us that we did the question correctly, because it's saying that it's telling us where the guy is first at, or his origin, which is at the bottom. So x, if you think about it, if it's 100, it means he's all the way at ground level. And yeah, so the other value of x is 13. And once you get that, you're looking for the height, which is 100 minus 13, which is 87 meters high. So therefore, the maximum height of the guy with his new mass is 87 meters high. There we go. Also, I want to give special shout out to Mr. Morin and Barbad and Liam, and also on YouTube, the channel called Physics Teacher, for inspiring me and assisting me with this question. Yeah, that's how you solve it. Good luck.